Hi, Joe Cerrone. Welcome to CAD 230, Introduction to Solidworks, and our weekly Zoom classroom meeting. Alrighty, so this week we're releasing Module 8, which is Modeling Threads, covers Chapter 9 from the textbook, and we have these three CAD models that we're going to create. This one is going to use I call it the Thread Wizard, because they had the whole wizard, and it's a great tool for creating threaded fasteners, either external or internal threads. And so Lab 8A takes you through how to create this part file with external threads. 8B has external and internal threads, and they actually kind of go ahead a little bit in the book. They jump ahead a chapter because this is actually an assembly, and if you haven't done SolidWorks before, you'll be able to make the threaded components, but to put them together you might need some assistance. My recommendation would be to look into Chapter 9, but I think it's a workable project. And then Lab 8C is this threaded nut, and they'll use a process where they'll create a triangular shape and a helix, and then they'll pierce that. They'll create a pierce sketch relation right at the end point of the center line and at the end point or the start point of the helix, and then they'll sweep cut that to remove the material. And so you can use that technique on any CAD system, so AutoCAD and all these other older CAD systems. What the thread tool does is it automates the threading of the part. And so if we take a look at the SolidWorks, and here's our thread tool right here. And what we can do is we can right click on that and we can edit that feature. And what you'll notice is that you'll get the threading options that you'll pick up. And so you'll pick up on the starting point of the thread. And what they recommend you do, this one looks like it's a little bit off, and it is, because the thread on here starts and it doesn't have enough run out. And so what they recommend you do is you offset this by, let's say, 0.1. And let's reverse that. And so let's flip it the other way so that the thread starts off of the part. And then this is a machinist technique where you'll create a relief for the threading tool so that as it cuts, that it has a place to go and end and then come out, come back in, it'll feed, and then thread at a specific depth and RPM using a G97 G code to create thread. And so once we've done that, I can then green check mark it here. And now you can see the thread has a starting point. And so you can get the nut onto the threaded part. Threads are great for working with 3D printing. And so if you want a quick prototype and you don't want to jump onto a lathe and have the tooling all set up, you can 3D print these. I'm finding when I 3D print something like this, I'll orientate it vertically so that I'll get perfectly cylindrical shapes. They have a tendency to be a little bit egg-shaped. But that's the thread tool. And then if we look at some of the other techniques here, like with the nut, what we're working with is we're working with a helix that we'll create. And so we create this helical shape. And what we do is we work with the pitch, which is the number of revolutions per inch, so that we can get that specific thread type dialed in. And then we sweep cut that once we have that pierce relationship established. And so you can draw this shape for the cutting tool and then sweep it and then cut it, and then you can see that we'll get this thread pattern. And again, we can 3D print those. What I do find is when I work with 3D printing on these, you can set up a high resolution level, and then oftentimes I'll chase it with a mechanical die or tap to make sure that it comes out perfect. And then we have these other components here. And again, we're using the helix technique and the cut sweep. Where we dial in this geometry. This should be 60, it's off by 1 degree. But again, you know, as we work with it, we have a Pierce relationship at this midpoint on that helix, and then we sweep cut that. You have to be a little careful. You don't have to cut threads onto every part when you do mechanical assemblies, because what happens is it slows down the processing power of your CAD model. Let's say we had 20 or 30 of these in an assembly, and then we had another 20 or 30 of these nuts and bolts. Well, it's got to process all of these. And so there are other techniques that we can create threads, which basically show it as a bitmap image. And so you can see that it's a threaded, but you don't necessarily have to cut the threads. The threads are great for prototyping. So those are our SolidWorks assignments for this week. As we take a look at the D2L system, we'll create these 3 threaded fasteners. It looks like I made the last one. Well, it looks okay. I'll come back to that. And then from a due date standpoint, there was a little issue with the midterm and lab 8 having the same name on it, so I separated them out. Everybody turned in the midterms in the right place, and so I created a lab 8 folder. And then lab 9 will look at assembly modeling. And so as we progress through the course, people did a great job on the midterm exam. Again, the option to take the industry-related CSWA exam is out there as we get closer to the final exam, which is going to be in about 6 weeks. And I can give you a voucher if you would like to get that industry certificate. Alrighty, so that's our Zoom meeting in what we're working on this week. If you have any questions, you can email me, and if you have any issues that you'd like to come in and get some extra support, we are available at the Skokie campus on Sundays in room P132 from 8:30 until 12:30, and on Thursdays 2 o'clock until 6 p.m., and then online on Fridays, and that's at 8:30 in the morning until 10:30. Just send me an email, let me know if you need any assistance, and we can get you some support either in person or virtual. With that, I'm going to end the Zoom meeting, post it, and open things up for questions.